Alright, now for this part, I'm going to discuss about how to using the probability density function, this probability density function to find the probability of a certain region, right? So if, for example, if I want to find the probability of x less than, right, of x less than 2, right, x less than 2. So we have to refer to this interval here, right, which 2. Okay, I can just sketching here the 1, 2, 3, 4, 5 up to 6, right? From 1 up to 6. But I have to divide this, draw a line here. I just to show you, right? Just to show you. Okay, this is not a method. This is just to show you that after 3, right? After 3 to 6, right? 3 to 6, the function here will be 6 minus x over with 15. Right? And the function for this interval will be x minus 1 over 5, right? From 1 up to 3, it will be x minus 1 over 5, right? So now if you're asking to find px less than 2, right? Px less than 2. So you have to look at the interval here, right? From less than 2 means what? X less than 2 means that it's 2 and less, right? Less than 2 means this region here, right? This region here. So there are no, below 1 means that after less than 1, there are no function, right? No function. So it means 1 up to 2, okay? Integrate from x less than 2 is actually this region, because this density is only defined for 1 up to 6, right? So less than 2 means that 1 up to 2, all right? Integrate from 1 up to 2 for what function, right? This function. So x minus 1 over 5 dx. If you evaluate this, then you will get the probability for this. Okay. So how to do it? Very simple. You can x minus 1, this whole thing linear. Just put a square here, right? Plus 1, 1 plus 1 divided by 2 times with 5. Okay. From 1 up to 2. So you have x minus 1 to the power of 2 over with 10 from 1 up to 2. Right? So you put 2. 2 minus 1. 2 minus 1, you are getting 1. 1 square, you are getting 1 over 10. Minus away, 1 minus 1, 0. 0 square, so 0 over 10. So the probability that you get will be 1 over 10. Right? The probability of x less than 2 will be 1 over 10. So means that if you're interested, right? If you're interested, right? This is for your extra knowledge. If you're interested, you can actually go and evaluate this area here. The area here, area under the graph here, from 1 up to 2, will be actually giving the value of 1 over 10. Right, 1 over 10. So you must have a knowledge of, when you're doing this, you must have a knowledge of graphing also. Means that, what is the meaning here? What is the meaning here? It means that the area under the graph for this region less than 2 is 1 over 10, right? As you know that the total area, right, will be 1, right? So now you know that it's 1 over 10. Okay, for your now, I have to remind you one thing is that, let's say if the question is asking you to find the probability of x less or equal to, right, less or equal to, right, the answer will be the same as px less than 2. For continuous random variable, the equal or without the equal, they are actually represent the same thing. It's represent the area under the graph. All right, the equal and without the equal is the same, right? Because there are no probability under a line, right? So it means that if I asking you for your knowledge, so if I said px equals to 2, there is no probability, okay? The probability will be 0, right? So it means that but for discrete random variable is different. The continuous random variable, we never talk about discrete, okay? This is discrete. So when talk about px equals to 2, there is no probability, okay? There's 0. So and this will be the same. So means that if you know that x less than 2, the probability of x less or equal to will also be 1 over 10. Alright? Okay, let's evaluate another probability. Alright, let's say they ask you to evaluate the probability of x between 2 and 5, include the 2. As I tell you that equal or without the equal is the same, right? The probability is the same. So it means that you can just integrate from 2 up to 5. Because for continuous random variable, we talk about the area under the graph. All right, area under the graph. So means that the area for equals to 2 is a straight line, right? There is no area, right? There is no area for this, right? There is no area for a line. Okay? For a straight line, for a vertical line, there is no area, right? So either equal or without the equal, equal here, no equal here, equal here, got equal here, no equal here, 2 equal, 2 got no equal. Means that you know my meaning, right? So means that either they are anything, okay? The outcome, the probability will still be the same, right? Just now the question is given you, so between 2 and 5, right? So you just integrate from 2 up to 5, very simple, okay? 2 up to 5 for fx dx, right? For fx dx, for this function. But you have to be careful because the interval might different, right? Because from 2 up to 5, right? From 2 up to 5, you see carefully, from 2 up to 5, there is a change of function, right? So from 2 up to 5, you must see that 2 up to 5 is from 2 to 3, 3 to 4, right? So I have to actually rewrite this to two different functions, right? From 2 up to 3, right? You see that there is from 2 up to 5, right? 2 up to 5. So, but for 2 up to 3, this region here, 2 up to 3, the function is 2 up to 3. The function is x minus 1 over 5 dx. Then continue from 3 up to 5, right? 3 up to 5 because it's between 2 and 5, right? So from 2 up to 3, this is the function. From 3 up to 5, this is the function. All right? 3 up to 5, this is the function. So this is a proper way of finding the probability from the probability density function. All right? As long as you get this correct, then you already know the concept, okay, of evaluating the probability from the probability density function. So this one, if you integrate x minus 1 over 2 divided by 2 times 5, you have 10 from 2 up to 3. Same thing also, positive, integrate for this, integrate for this interval. So 2, okay, 6 minus x, and this one, 1 plus 1 over 2 divided by 2, right, divide by 2, and don't forget to divide by the coefficient in front of x, negative 1, right? So 15, so it's from 3 up to 5, right? 3 up to 5. So you have to evaluate this. Your integration knowledge must be perfect, right? So 3 minus 1. 3 minus 1, we have 2, right? 2 power of 2 will be 4 over 10. Minus with 2, right? 2 minus 1, 1. 1 over 10, right? Adding with this one, right? This one 2, 2. You have negative 15, right? Negative 15. So negative 15. And you're putting 5, right? 6 minus 5 is 1. 1 square, you're getting 1, right? Then you minus away, subtract, you negative, all right? Minus away. So you're putting 3, right? 6 minus 3, you have 3. 3 square, right? 3 square. 3 square, you have 9. 9 over with negative 15, right? Negative 15. So let's evaluate what is the probability. All right, after calculating, adding everything, we're getting 5 over 6. We're getting 5 over 6. The value of 5 over 6 here is actually represent the area. Okay, now we talk about 2 up to, okay, we talk about 2 up to from 2 up to 5, right? 2 up to 5, 2 up to 5. This area here, 2 up to 5, this area here, so we'll be giving you the value of 5 over 6. You must understand, right? So this will be the area from 2 up to 5. This will be, if you find the area, you are getting 5 over 6. It's actually represent the probability, okay, of this interval, right? So just now I have already told you that if you find the probability of 2x equal 5, all right, equal or without the equal, or we're having the same way of evaluation, right? Adalah sama untuk menilai semua ini, alright? It's the same, okay? You are still getting 5/6 because the equal and no equal here is not important in continuous random variable, alright? So, okay, let's look at another example. Okay, now I'm going to teach you another way of, let's say, okay, let's say there is a case, and I'm not going to evaluate for you, I just tell you the clue here, okay, the clue here. So, what if the question is asking us to evaluate the probability of x greater or equal with 2, right, 2.5, for example, 2.5, okay, yes, for continuous random variable, you can take a value, okay, between this interval, right? So means that it's not discrete, right? This is not discrete random variable. So if you say that x is greater or same than 2.5, you are actually integrating from 2.5, right? Because it's above, right? So if you look at this, you have 3, right? Here 3 and 2 and 1, 4, 5 and 6, right, up to 6. So if you said that greater than 2.5, 2.5 is around here, right? This is 2.5. So 2.5 and above, right? And above. So it means that integrate from 2.5 up to 6. 2.5 up to 6 fx dx, right? So if you want to find the probability for x greater or equal 2.5, it actually means from 2.5 and above, right? 2.5 up to 6. But you have to be careful that even though this fx is different for different interval, this from 2.5 up to 3, right? 2.5 up to 3, the function will be up to 3. The function is x minus 1 over 5 dx, right? And for later on, 2.5 up to 3 is this one, and remember it's from 2.5 up to 6, so 3 up to 6, for 3 up to 6, it will be 6 minus x over with 15 dx, right? If you evaluate this integral, it will become the probability for this, right? So I'm not going to evaluate for you. It's the same thing. You do integration, right? You're doing the integration, then you can evaluate. Okay, there is another shortcut here. Alternative. Okay, I just want to talk about more about the alternative here. Okay, I give you so that you're able to see the probability density function different. Okay, so some students may say, sir, can I using the 1 minus concept? Okay, the complement. So 1 minus means if you said px less more or same than 2.5, I also can say that it's actually equals to, right? You have to understand this concept here. Px greater or equal 2.5 is the same as 1 minus px less than 2.5. Alright, in continuous random variable, the equal or not equal doesn't matter, alright, as long as it's 1 minus px less than 2.5, right? So less than 2.5, right? Means instead of using this way, you can using another alternative here. So which is you integrate from less than 2.5. Less than 2.5 is this region, right? Less than 2.5. So from 1 up to 2.5, right? From 1 up to 2.5. So what is the function? X minus 1 over 5 dx, right? So if you want to compare between this alternative method and this one, definitely this one will be a lot easy, right? And they will have the same answer, right? The answer, the value of the probability will be the same, right? So if you're using this, you have to integrate two functions, right? Which you were wasting some time here, right, to evaluate this. So instead of this, you can doing this, right? You can see, so they want from 2.5 up to 6. So I taking the total probability from 1 up to 6 is 1, right? 1. So I take 1 minus away the probability here, right? The probability here. Then you will get the remaining probability, right? Which is the probability from 2.5 up to 6. This is, I suggest you using this, okay? I'm not going to do for you, I'm telling you, all right? Okay, I give you another situation. All right, okay, what if, okay, I am not doing for you, okay, I just tell you what if the question is asking us to evaluate the probability of x less or equal 4, right? Less or equal 4 means that 4 and less, right? Means it's all the region here, all the region here. So it's integration, okay? Integration for 1 up to 4, right? 1 up to 4. So means that because they said less than 4, right? Less than 4. So means 4 and below, right? 1 to 3, right? This is 1 to 3, this function. 3 to 6, this function. So now they want 4 and below, right? So it's for the property density function fx dx. But you have to further consider that this function is different at different interval, right? So from 1 up to 3, it's actually 1 up to 3 is x minus 1 over 5 dx, right? So later on, for 1 up to 3 is this one. 3 up to 4 will be 3 up to 4 will be 2, 6 minus x, 15 dx, right? If you evaluate all this, if you find the integral, blah blah blah, everything, you are getting your probability, right? You are getting your probability for this, all right? So okay, and alternative methods. You can also doing this way. So because this is px less or equal 4, right? So I also can rewrite this to be 1 minus something, right? Because the total everything here, the area must be 1, right? The total probability must be 1. So, and 1 minus with the one that greater than 4, right? You also can consider this. It's either this or this method. So more than 4. Either is equal or without equal is okay, right? So 1 minus 4 means that above 4, right? You take everything, the total probability 1 minus away the probability from 4 to 6. Then you will get the probability from x less than 4, right? Definitely. So then it's from 4 up to 6, right? 4 up to 6. And in this interval, this is the function. 2, 6 minus x over 15 dx, right? For me, I will doing this because it's a lot easy. I don't need to integrate this and substitute value and avoid some careless mistake here, all right? But you have to be very sure that you are doing the right thing, all right? So you look at this, I just integrate for this, all right? So after a 1 minus, I will getting the value as the same as this, right? You can try to do both, all right, if you want. So now I usually prefer this one, all right? I prefer this one for this type of cases here, all right? Okay, I think that's all. I hope you get the hint that I mentioned, all right? So hope you understand.